to our Mastering RFID webinar, Unlock Features and Functionality with IC Innovation. My name is Suzanne Gotfryd from Atlas RFID, and I want to introduce our two featured partners for this webinar. So we have Trevor Davis, who is the VP of Global Solution Partner Sales at Impinj. Trevor leads a team, who focuses on business development and sales for next generation RAIN RFID products, including reader and tag ICs in all verticals. He partners with OEMs to offer world-class RAIN RFID solutions. And then we have Steven Wood, the Director of Sales at Atlas RFID. Steven is a leader in the RFID industry and has helped some of the largest companies in the world with their RFID deployments. Working side by side with companies in all industries on the front line has given Steven a unique and practical perspective to add real-world examples to Trevor's IC knowledge. It's great to have you guys with us today. We're really excited about learning more.
Yeah, be here.
All right, and everyone's favorite time. So we're going to go over a few notes before we jump into the session today. So the session will be recorded, will be available online within a week. So check your email for that notification. Please put any questions you have in the chat for a live Q&A. We have 15 minutes to try and answer all of your questions, but if we don't get to them, we will send you an email with the answer. If you do experience any tech issues, try refreshing your browser first, but I'll be looking at the chat for any technical problems that people are having. The educational portion of the webinar will last about 45 minutes, kind of like I said before, and then we'll jump straight into the 15-minute Q&A and hopefully answer all of your questions. So remember, we do have polls and handouts. Both are available on the right side of your screen throughout the webinar. The handouts will be given right at the Q&A, and the polls will be throughout. So here is a quick look at the agenda today. We're going to talk about readers first, and then tags, and then walk through the available features and functionalities, and then Gen 2X, and then we have our Q&A. So before we get started, I'm going to launch into 3 quick polls, so bear with me here. So our first poll is, what would you say your level of knowledge or expertise on RFID or IoT is? We'll give y'all a few seconds to answer that. Okay, so we're getting a lot in the middle between knowledgeable and in the middle. So it's great to see that. We only have a few very knowledgeable and not a lot of brand new to RFID. So that's good. We'll be talking about some really technical stuff today, but we'll also keep some basic stuff as well. So our next poll is going to be, what is your primary RFID application? I know there's not a lot of choices, but see if what you have fits in there. All right, so we're seeing a lot of asset tracking, which is pretty standard, and inventory management. So that's great to see. I think we're going to talk a lot about those 2 applications today. And our last poll is going to be, do you know the difference between finished readers, reader modules, and reader ICs? Just going to take a little information before we get into the topic. Okay, looks like most people do know. Well, actually, it's pretty split. So that's awesome to see.
Well, hopefully we can impact that poll when we're done.
Yeah, exactly. Exactly. Okay.
Information, everybody. That's great.
Yeah, that's great to know. So we'll get straight into it. So before we jump into the features, which I know a lot of people are excited about, we really want to provide context about the different types of reader solutions available to you. So Trevor, can you walk us through the 5 different types of RFID reader solutions and provide your insights here on each one of these?
Sure, you bet. Yeah, in fact, team, the way that we'll talk about this, we'll talk about all the different types of readers here. Then we'll talk about reader tags, or tags that go on your items too. So we'll get sort of both sides of the link here in a minute. But I think it's worth noting, let's start at the bottom of the slide here. So Impinj makes both the top of the slide and the bottom of the slide, actually the Impinj E family of readers, and also the finished reader, the one you're seeing up there is the R700. That's at the top of the slide here. But the idea is that depending on what you're building, you can find different levels of integration along the lines on solutions that different partners offer. So at the very, very lowest level, if you were going to build a handheld or a fully embedded system, you might use one of our embedded chipsets. So the E710 is what's noted there, and you do a full PCB design around that. But that chipset, think of it like an analog plus digital controller, where it has an ARM controller inside with the analog front end to run the RFID, and then of course the firmware and the decision making and processing of the RAIN protocol, the RAIN RFID protocol. So that's all embedded in that single IC. The next layer of integration is into a module itself, and that module can be certified by region. It's built by a partner who's a RAIN expert. And normally what you can do is take that module and then put that into your single board compute or your system that allows you to bring RFID a lot more simply into your system without having to understand the real root of the issue. And in these cases, the modules will have their own SDKs. And so you don't have to do a chip level based design to get the benefit. In fact, we see a lot of even handheld thin form factors using modules because it catapults people 9 months to a year's worth of RFID learning over doing a chipset design themselves. Go up yet another level of integration, you've got a single board reader. And if you look closely at the picture there on the left-hand side, you can see it's got a pin set where you can get data out. On the right-hand side, it's got the actual antenna connectors. And so that thing is really in and of itself a full reader where it's got antenna outs, it's got the processing through the module, it's got IO out, and that's meant for very small form factor embedded solutions. Say you were building a drone or a robot or a vending machine, you might use something like that single board reader if there's another sort of brains of the system that's in there. Go one level up, you've got a modular reader. And so think of this as a reader without a case. So it's meant to be more embedded into a system or a solution. If you're building your own encasement, if you are putting it maybe as part of another system, a vision system, you might use that. And if you look closely at that picture, you can see, in this case, it's got 4 antenna ports at the bottom, and then a whole bunch of different IO ports on the side. It's got GPIO, it's got USB, it's got some other connectors. So this might be something that you would expose if you're building also like sort of a general purpose or have multiple connection points in that reader. And then the final, most integrated solution is a finished reader. In this case, this is a picture of our R700. It's the most performant 4-port reader in the world, fully integrated. It's got its own web UI for configuration. It's got its own software stack that you can integrate into. It's fully configurable. It's got a high performance case, so you can stick it just about anywhere, run into it with a forklift, and you're probably all right. So it's sort of the easiest way to get into the RAIN RFID space. And so, yeah, there's lots of different ways that you can integrate. And I know the Atlas team has lots of experience with the different solutions up and down the scale here too. So,
yeah, I mean, Trevor, that's a great explanation. Just to kind of provide a little bit of color on how these devices are being used in the real world. I've actually got an R700 with me here. You can see it's robust. It's got the finished ports that are accessible with coax to the antennas. You can see your IO ports here, your Ethernet, GPIO connectivity. So, the Impinj team, takes this unit and makes it accessible, right? It's very easy to set this reader up and begin reading tags within moments. Like, I don't have a strong technical background. I focus on engineering applications for customers, but even I can take the R700 reader, get it set up, get it powered up, and begin reading tags and reporting those tags. And the Impinj has done a really great job of putting that in place to make that possible, right? So as you can imagine, if I can do that, it's at a place where it's really easy to deploy and scale within your organization. So where we're seeing R700 or readers like R700 is deployed at an enterprise level, very, very quickly, right? So, and we'll talk a little bit more about it, but the IoT, capability, the interface that the R700 has allows you to have recognizable ways to move that data to your back end to an endpoint. But where you're seeing R700 is at dock doors, right? So the workhorse, the powerhouse, where you're needing to read a lot of tags in a short amount of time. If you can imagine, 500-600 things on a pallet moving through a dock door, the R700 is enabling that capability. It's on assembly lines, monitoring work in process, right? Ensuring that the job is staying on schedule. It's in warehousing, watching items move from one place to the other, right? And kind of creating that breadcrumb trail. As far as the modular reader goes, I kind of like to think about this as using my imagination, right? Thinking about what do I need? Do I need a certain specific unique power source? Do I need it to be powered via vehicle embedded into a vehicle, as Trevor mentioned? Another aspect is what type of interface. The modular reader kind of gives you this option to if you needed to use 5G connectivity, right? Like modular readers are something that you can work together with the Atlas team to design and to meet those specific requirements. It's sort of like a Swiss Army knife in that you get to design what you need out of that device. A little bit lower, we have the single board reader, which I have one of those here with me too. So it's an embeddable device, but I would kind of think about the single board reader as embeddable but lower effort. As Trevor mentioned, it has these more standard I/O options, your MMCX antenna ports. So it is embeddable to something like a vending machine, robotics, whatever it may be. But it is easier to integrate because of those interfaces. And we kind of think about these as sort of a mid-volume. Like if you don't have something that's going to be mass produced, but you want an embeddable solution, this is a great option, which saves you a ton of time on the design work. And then a little bit lower is the actual module, and you can see on the module you have the pins on the back of the module, the pads on the back of the module that allows you to create a board and design a board that's going to accommodate these points to enable that RFID functionality into that vending machine, into robotics or whatever that may be. But this is typically what we would see in mass production, thousands of units in a production process.
Okay, and with that, before we get to our next slide, I want to go add one more poll. I promise it's the last one for a while. So do you know the difference between finish tags, inlays, and tag ICs? Go ahead and... Well, a lot of people know this one. It's great. All right, yeah, most people do understand that. So let's just jump right in since it's not a pain point. So now that we've walked over the types of RFID readers, let's do the same with tags so that we're all on the same page before we get to the IC features. So that Impinj makes reader ICs and tag ICs. So Trevor, do you mind walking us through these three types of RFID tag solutions?
Yeah, you bet. In fact, there's a little bit of conversation going on in the chat about tag distance and reading, and we'll get to that in a little bit. I have some data to show you in a little bit. But one of the things that I would say one of the most fundamental mistakes that we see people building when they're building RFID solutions is they think almost exclusively about the hardware, the reader, the thing we were just talking about, and they don't think as much about the tag side of the link. And the truth is the tag is a fundamental part of the RAIN solution because it's both sides of your wireless link. It's like having a great Wi-Fi in your house and having a 12-year-old computer with last generation Wi-Fi. Like the signal strength will not be taken advantage of if you have a lousy receiver. And the same thing's true of tags. And so the phrase you all should write down on your notebook and emblazon in your brain is tag strategy. What is my tag strategy? And the tag strategy means what is it? How do I think about what the tag needs to do in my solution? So let's walk through this real quick. If we start at the top here, we Impinj make the tag ICs. Those tag ICs are about the size of a grain of sand. Believe it or not, on a single wafer, we get about 600,000 tags out of a single wafer. It's incredible. I'm still blown away by the technology. Those wafers get inserted into a machine, and raw, what they call inlays, so that's the middle part, come by the wafer, and a pin is essentially pressed down on that wafer, and that tag is popped off the wafer, and it goes, and it sits right where it says, right where there's those two little circles in the middle. Those are essentially the pads that pick up, and that's the antenna, that funky crab shape there in the middle of the slide. So, and then finally that inlay, which will be put on like a PET, a clear material, it'll have different types of adhesive, that gets stuck to all kinds of different tags. It could be a hang tag on a shirt. It could be a tag on your windshield for receiving cars as they drive by. It could be anything. It could be a entrance into a building. It could be a tote that's carrying food. So what you really have to be thinking about is, in my tag strategy, am I finding the properly built and tuned tag to serve my problem? So for example, having a very low cost, small tag may not give you the read distance that you want, because you're not accounting for the density of tags in a given read zone. And so every one of those antennas on the inlay there are specifically designed for performing under different circumstances. And so actually, Atlas, you guys can talk about this, Steven. You guys sell packs of tags with lots of different variants in there, so people can run testing to see what types of tags suit them. And it could be everything from adhesives are different if you're using it in a cold environment or a hot environment. Size matters for creating a longer distance signal, for example. Tags that are designed with horizontal polarity, that has a strong horizontal polarity because they're hanging. And so if your reader is above them, now you're trying to read the long end of the tag. So there's lots of different circumstances around the tag. But if you haven't thought as critically about the tag as you are about the read point, I think that's oftentimes what we find is a big weakness in solutions that are being deployed around the world.
Yeah, I mean, I've actually brought some tags with me to kind of show and tell a little bit. You know, we have sort of at the most basic stage a clear, dry inlay. This is, you know, an aluminum antenna inside a PET with the IC there in the center, and it doesn't have an adhesive, but you know, we can quickly adhere, you know, add an adhesive to this to allow you to adhere this to, you know, an item, whether it be a box or a apparel or whatever it may be, right? It can be used in a lot of use cases. You know, this is kind of taking it to the next level, where we have a paper face where we can run this through an RFID enabled printer and, you know, print and simultaneously encode, you know, data to the tag that's relevant to your application. In most cases for tags like this, where obviously, you know, retail is really picking up steam in terms of leveraging the technology to increase inventory accuracy, grease the skids on supply chain, ensuring that you know, those items are on the shelf for sale. This is commonly where we're seeing these tags. So as you can imagine, you know, the tags are increasing substantially in terms of volume within the supply chain. But, you know, there are more complex tags, like an asset tag like this one that is designed to, you know, live the life along with the asset that it's attached to, reading the tag hundreds of thousands of times, you know, throughout the course of you know, the lifespan of that asset. One of my, you know, favorite applications that we're working with a client on is vehicle fleet management, and they're, you know, applying tags like this to their vehicles so they can see their vehicles come on and off different lots and yards within their organization, so they can pinpoint with not only GPS but also have the confirmation of RFID that transaction did indeed happen, seeing those status changes. But tags, you know, like Trevor was saying, tags come in all sorts of shapes and sizes. I've actually got one more somewhere around here it's a small loop tag, right? I mean, a very small tag for, you know, pharmaceuticals, or, you know, tracking critical cables, maybe in your data center or something along those lines that help enable those applications to become a reality. So it is really important to test a variety of tags, ensure your tagging strategy is in a good place, because the tag is certainly, it seems like a small piece of the application, but it's critical in order for that application to be successful.
Yeah. Trevor, do you want to add anything there?
Yeah, I was going to add one more thing. The one thing that I didn't I didn't hit on very hard was, you'll notice here at the top of the slide, this Impinj M800 series. The other thing that people should be mindful of is when they go out and they're talking with their tag partner and they're looking for a tag, there are multiple generations of tag chips that are out in the world. Our latest latest generation of tag chips is M800. We'll talk about it in a minute, but we actually get 1.5 dB of gain just by moving from generation to generation, M7 to M800. And this tag is the most performant tag in the world against any other competitive chip. So not only do you get quality, not only do you have to worry about the inlay and the tag and the antenna design, but you should also have a care about the tag that's sitting at the intersection of that antenna. And my encouragement would be ask your tag provider or work with folks that can get you to the M800, get you a tag solution with the M800 in it, because it'll give you from the very get, it'll give you a higher performance.
Yeah, and now that we've talked a little bit about tag strategy and tags and the readers, let's talk about the communication between the tag and the reader. So this is a great slide that Trevor is going to walk through that really talks about what happens during that communication between tag and reader.
Yeah, thanks, Suzanne. Yeah, I like this slide. It's hopefully pretty simple, but I think too, when you're breaking down and thinking about your solution, the terminology in here matters because it depends on what problem you're trying. It depends on what problem you're trying to solve. So here's the basics of RFID. So from the reader itself, so that's that R700. It is sent. We call it a reader. I don't know why. It's a transmitter and it's a receiver, so it does both jobs. So it sends a signal, it resonates off the tag, and it reads back that. And so the strength of its signal, of its transmit, and the sensitivity of its read are the big factors for the reader. So it generates this transmit power. It will head over the antenna. If you have a poor antenna in the system, the wrong antenna in the system, that could greatly affect your performance, because if you're not sending the signal into the right direction to hit the tags in a way that will resonate. So antenna design and antenna choice is fundamental. You get loss of that signal along the way. So depending on what's in how much distance, there's been a bunch of dialogue in the chat about that. You get signal loss because of distance, you get signal loss because of materials in the way. So you need to be mindful of the distance that signal is traveling and the interferers in that path. It hits the tag, and at the tag, there still needs to be enough intensity in that signal to radiate or to get the tag fired up so that it can then send back a signal. So that's the sensitivity at the tag must be greater than the tag sensitivity itself. And that's why that antenna design is so important. It comes across the tag, the data is generated and comes back the tag. And so now what the tag is doing is backscattering. And so this is your reverse link. So the first to the link was your forward link, and now you're on your reverse link. And so now in the same way, when you're thinking through your solutions, you need to be figuring out, am I forward link limited, meaning I cannot get enough signal to my tag? Or am I reverse link limited, meaning that for some reason the tag is not sending enough energy back to my reader to be able to be captured by my reader? And sometimes that's a tag problem. Sometimes it's a signal loss problem. And sometimes it's a reader sensitivity issue, that you're actually getting a fair amount of signal back, but your reader may not be sensitive enough, which is why we talk about sensitivity of that R700 reader being best in class. It's sensitive enough to hear that very low signal that's coming back from the tag. So understanding this forward link and reverse link and backscattering concept is really important for problem solving in RAIN RFID. And I'm sure Steven's seen a million applications that fail in any one of these phases, right?
Right. I mean, like this it's critical to, I mean, that's why it's so critical to test a variety of tags, not putting all your eggs in one basket, so to speak. Ensuring you're selecting the best, because, depending upon, antenna design, the material that you're attaching it to, the IC chip that's being used, right? What memory you need to store on the tag. There's so much to think about when it comes to tag selection, but putting the tags in the environment and testing this, thoroughly is a big piece of ensuring you're selecting the best tag for that application.
Yeah. That's awesome. And now that we've covered tags or readers, tags, and communication, we're going to jump into features and functionality. So let's jump right into the slide, the reader features. So Trevor, do you want to kick us off and talk about some of these awesome features?
Yeah, you bet. So on the reader side, There's a few things that are worth considering when you're out doing your reader research. And I think some things that Impinj does well. I've been at Impinj for a couple of years, and I love for you guys to evaluate and look at our products. But of course, we like to stand on our merits. And so it is important for you to do your research. But a couple things. One, on the R700 side of things, and we'll talk about Gen 2X in a minute, which is a performance boost over the standard Gen 2X protocol. But our readers are leading performance. So one of the things that you want to look for when you're evaluating a reader is the sensitivity. That's that return link capability. So if you have very low signal tags that are further away from the reader, maybe poor performing tags, if they happen to be in your ecosystem, choose a different tag strategy, get different tags. But if you have poor performing tags today, reader sensitivity really matters. And so our readers are the most sensitive in the world. And you can run, they actually are a Linux-based OS. You can run your own algorithms. We have the ability to build caps on top of our SDK that gives you new algorithm capabilities. So it's a really, really powerful reader tool. It's also, remember, these are network appliances, so they'll be on your network. And so you want to have enterprise-grade reliability and security, which we do. And then ease of use and getting at the data is really important too. And so we have what we call the IoT device interface, which is it's how you access the on-reader programs and get the data out in a way that you can use it in your systems. And then you can also, over the network, you can actually configure the readers through our web UI, which is really nice for deployed systems because you can engage with a reader through different iterations of proof of concepts or adjust the reader, for example, if you see performance degradation for any reason. So it really matters sort of the capability of the hardware itself all the way through the interface and the way that you engage with the reader so that you have the best deployment and the ability to be flexible in your deployment. Because the reality is, circumstances change and environments change and warehouses change and stuff gets moved around. And so you need to have some level of flexibility in your system to make sure that you have the best performance possible.
Yeah, I mean, I think that, to hit on your point again, Trevor, about how, the IoT device interface really enables applications. I mean, a RESTful API, a really common output method like MQTT, which really enables you to consolidate your data to a certain place and pull what data you need from that broker, right? Like it's really enabling things like that, really taking RFID to, further into the IoT space, it being IP addressable, easy to configure, certainly easy to use, like I mentioned earlier. And then, the sensitivity, which I can kind of talk about this when we jump into the IC features. But, a decade ago, our biggest challenge was reading tags, right? Like a 70% read rate or 80% read rate. Well, just as common today, we have situations where we're reading too many tags because then the tag sensitivity and the reader sensitivity has increased to a place that's allowing for that, right? And if you were to give me the choice of, which situation to troubleshoot, I would always, I would choose the latter, right? Being able to, if I have too many tag reads, right? Well, I have the option to dial back the reader, filter certain reads, leverage a software platform to, decide which tags that I want to report versus those that I don't. So the increase in sensitivity has come such a long way. And just the last 10 years, it's really enabled us to make more applications possible. So, it's certainly exciting as the technology continues to evolve.
Yeah, definitely. And now that we've talked about kind of the reader features, let's jump into Tag IC so we can definitely keep going with our tag strategy conversation because I feel like that's so important. So Trevor, can you walk us through some of the things we can see on Tag ICs feature-wise from Impinj?
Yeah, you bet. So there's a couple things to consider. One is, I would say, quality of capability of the Tag IC itself. That's the 1.5 dB we were talking about, that M800, just pure chip v chip in the world. And then there's the tag reliability. One of the last things you want to do is go through all the trouble to start to tag things and then have quality issues along the way. So let me address sort of both of those things. So on the M800, that's where you get that 1.5 dB sensitivity. The reason that matters, a couple things that are happening in the market. One is tags want to get smaller and smaller. If you get smaller area, they cost less. It's that simple. And people want to keep driving out costs. So if your tag gets smaller, your antenna gets smaller, it gets harder to read. So you need a more capable IC that's sitting on that smaller tag. People are also embedding tags. So they're putting tags in hang tags, they're putting tags in materials, they're even putting tags inside of tires, for example. So you don't have the ability to cut off a hang tag, for example, and walk out of a retail location. And so with embedded tags, you can imagine there's a lot more material impeding the signal that we were talking about on either the forward or back link. And so having a capable IC is sort of the fundamental start of all of that. So that's that tag readability. The next piece of it is it going to stay on that tag? That some of these tags get attached to totes that get banged around and smashed and stacked, and boxes that get pushed together. And if you don't have a highly reliable tag manufacturer and tag recipe, we call it a tag recipe, where you put that tag chip on and it can bend and twist and still retain its electrical characteristics, then you run the risk of losing the insights to that tag. And so you want to have a very high quality tag also, but at the right price. And I've highlighted two more features here. One is auto tune. So we have a really unique capability in Impinj tags where it can actually, based on either manufacturing variants or the material that the tags are being put on, our tag can actually tune itself as it powers up so that it has the highest performance to help with that read link. And then we actually have a very specialized feature too, we call protected mode, which is, and this is big for European countries, where once a tag is read and a product is purchased, for example, you can actually quiet that tag in a way that cannot be recovered without an associated secret key or private key. And so personal data can be separated from a tag, a product that might be tagged and is carried out the door by a person. So some really unique things from a tagging standpoint. I know some people think, boy, these grains of sands can't be that complicated. No, they can actually be very complicated. They're very sophisticated and they unlock a lot of capabilities. And that's why the tag strategy is such a critical part of thinking about your solution.
Yeah, so I mean, if I could just add just a practical application for protected mode, it is a relatively newer feature from Impinj on the M700 series tags. But one particular application is a product manufacturer that is embedding a tag in their product, and in many cases that product will come back for maintenance and repair. But they embed that tag in their product, or it's not necessarily embedded; it's just adhered. But before it leaves their facility, they turn the tag off, if you will. So while it's with the consumer, the tag can't be read, and if it can't be read, it can't be identified, can't be removed, or less likely to be removed. So when it is sent back, the manufacturer lights the tag back up, awakens the tag, and can see, yes, we did indeed manufacture this. It was on this date, this time. It went through the right distribution channels, and confirm all of that information. And it's just a pretty unique, interesting application in a way that they're using protected mode to make their processes more efficient.
Yeah, and that invisible mode is really cool for retail and for authentication as well. So we've heard a lot about both of those with the protected mode. So now that we have seen increased the features, we're going to jump into Gen 2X. So hopefully you guys have heard about Gen 2X from the news, from Impinj, from us. But Trevor, can you walk through kind of what Gen 2X is and what we can expect from it?
Yeah, this is really, really exciting stuff. This industry works really hard to get very small incremental improvements in performance or price decreases in tags. That's been a big driver for the industry. But Gen 2X is pretty revolutionary. So think of it, so Gen 2 is the standard RAIN RFID spec. That's how we all talk a common language across all the different products so that everybody's compatible. What we realized was that there were some capabilities with Impinj when you're accountable for both sides of the link, where you make both the tag and the reader, you can be Gen 2 compliant and do some extra things. Not exclusive to Gen 2X, but I'm sorry, not exclusive to Gen 2, but additive to Gen 2. And that's why the X, extra stuff. And so you get extra stuff with Gen 2X. So it's easy to remember. And really, we focused on sort of two different feature set buckets, let's call it. We call it a toolkit. but around performance and protection. On the performance side, we have, there's just different read modalities that we've allowed in Gen 2X when you have an M800 based tag on your reader and one of our reader, either our reader ICs or our readers. And so you get a lot better tag sensitivity. We'll show you the data here on the coming slide to sort of show how this affects. You get better range. You can get better speed. Speed can be used for many things. It can be used for finishing an inventory round quicker and moving on to a different accountability, making quick decisions on motion, for example, somebody leaving a store. Or if you can finish an inventory faster, you can run that inventory multiple times and look for additional data on your tags to make sure you have very high accuracy. So you can use range, readability, speed, all in different ways to trade off to get more performance out of your system. That goes to some other things like decluttering, managing an environment, understanding what you want or what your tag of interest is versus Steven was talking earlier about stray tag read controls. So all of these features help with those kinds of things. The more headroom you have in your ability to get good data back from the tag, the more time you have to make decisions with that data. And so this distance and readability is a really, really important feature. And there's incredible gains with this Gen 2X capability. On the protection side, we've done a lot more with data protection, the authentication. Suzanne was just talking about that, which helps with consumer privacy and return fraud. I think it's so interesting. I was talking with a big retailer. One of the biggest ways that they are defrauded is people will buy items, they'll go home, they'll use those items for some amount of time. They'll come back in, buy the same item a second time, take it home, and then return the old item. Now, without some sort of an authentication process, their goods just keep getting, they just keep getting old returned goods and new goods keep leaving, and it's high value goods. And so RAIN RFID could actually quite easily solve that problem because you can tell exactly when each item was used. So a lot of stuff with fraud and consumer protection too. So I'm sure, Steven, you've seen lots of examples of where readability and range and speed and decluttering all make a big difference in deciding what, sort of the clarity of the data you get back in a solution. Yeah.
Yeah, I mean, no doubt. I think, the speed of the read is kind of interesting, right? RFID is already, fast, quite rapid, right? Being able to read. I mean, I think back to my retail days. I worked for a retailer for 6 years. While I was there, we were deploying RFID, and we were leveraging it to take inventory and monitor on floor versus in the stock room, like what we didn't have represented on the sales floor. But how rapidly you could take inventory of the men's denim department, 3,500 reads in what felt like no time. But as the tag population increases in supply chains, increases in retail stores, in warehouses, right? We're putting more tags on pallets. The how rapid that read happens is going to become even more critical. Again, I think I mentioned it earlier, you have maybe 500 or 700 items on a pallet or more, right? You need to be able to read that rapidly as it's transitioning through that point. So, how, innovations like Gen 2X are taking this to the next level is really exciting. And again, enabling more applications to be possible with the technology. Another thing is, with better readability is, this year, the product that you're pushing through your supply chain may be product A with this material, with this format, whatever it may be, right? But next year, you might change it a little bit, right? And this is going to allow you to, have that overhead in your system so you can make those adjustments. So when that does happen, you make those tweaks and you're, again, getting that 100% read rate objective. So a lot of, these innovations are really exciting, continuing to move the industry forward.
Yeah, and I just want to say with that too, I am marking all these as questions. So don't feel like if I don't reply to you that we don't have it. We're getting all of the questions, I promise you. And we're going to see, now that we've seen the Gen 2X performance and protection, which is on the M800 series tag chips, we're going to go to the next slide and see some examples of that. Trevor, can you walk us through this demo setup that you have?
I can. It's a little bit of a complex slide, so bear with me for just a minute while I describe it. All right, so here's the idea. So first of all, the picture on the left is essentially a foam board, a pink foam board that acts effectively like air from a dielectric standpoint. And each one of those, you can see there's 4 tags that look like a square. That's a square foot of tags. And so we call this our bowling alley test. At the far end is one of our readers. And so it's sending a signal from the far end down towards us. So that's the visual in your head you should have. And that is effectively what's shown over on the right-hand side. So each of those little squares there have different size tags. They're actually very small tags. We had to make very, very small tags to show sort of the limit where we could limit some of the signal for the purpose of testing. But the primary point was to show the difference between Gen 2 and Gen 2X. So now over on the right-hand side, let me just talk about the Gen 2 column of data here. So you can run these readers in many different mode types. Fast mode, medium mode, slow mode. And slow mode theoretically is you're spending a lot more time sending signal, receiving signal, analyzing signal. And so in theory, you should get a pretty a reasonable tag per second read, and you should get more tags read over a given period of time. And you see that slow mode has a lot more greens, a little bit of yellows. So that's sort of, you can see there, it's maybe halfway down, not quite halfway down, 40% down the bowling alley from right to left in this picture. In medium mode, you're going to be moving faster. And in theory, you would get more tag reads per second. But strangely enough, in medium and fast mode, you actually get less tags per second. And the reason is you're not able to get you don't have enough signal strength in Gen 2 mode to get enough data back to make a positive read of those tags. So even though you're theoretically reading faster, you're getting less effective read rate because you're not collecting the data on the tag. So that's why it's a little counterintuitive. And you can see here as you go fast, you get a lot less tags read on the bowling alley because you read and are not getting enough information back. All right, so that's Gen 2. That's sort of our baseline. Then we put the reader into Gen 2X mode. So it's using now the Gen 2X capability, the processing and signaling that we use in Gen 2X. And if you read in slow mode, for example, look how much more of the bowling alley you're able to read. Now you read 63 tags per second, which isn't super fast. It's much faster than the slow mode in Gen 2, but you get essentially 177% more area coverage than the baseline, which was that fast mode baseline there. If you go now up to fast mode in Gen 2X, you're still getting about that 40% tag read. But look how fast that is, 324 tags per second. So the comparison here is actually, if you're in fast mode Gen 2X, you get better coverage or more comparable coverage to the slow mode in Gen 2. So you can use this Gen 2X to do a couple things. One, you can get a lot more distance. Imagine this is sort of floor space, for example, of a retailer where you're sending out a signal and collecting information, or a warehouse. You can now cover 177% more area just by using the same hardware running in Gen 2X mode. Or you can get 7 times more tags, say that fast mode in Gen 2X versus the slow mode in Gen 2, 7 times more reads. I told you this was a complicated slide, Suzanne. But I'm hopefully be coming across as you can go real fast and get the same data in Gen 2X as if you were running real slow in Gen 2, which means you can inventory a lot more times and get a lot more clear data. Or you can run in slow mode and get a lot more coverage, which allows you to do a couple things: get a lot more data or overlapping signals so that you get clarity of your space. Or if you're doing an installation, you could theoretically install a lot fewer readers because you have more coverage. And so you can actually drive costs down just because of the performance of the reader. So hopefully that made sense. I get real excited about it because I've seen it solve real problems. I was at a customer, they were making a cabinet that had a Gen 2 reader in it. They got 23% read rate of all the material, and it was a medical cabinet. They put Gen 2X on that same reader. They put the Gen 2X firmware on there. They got, in the same circumstances, they got 100% read rate, from 23% to 100%. Just by the change of the Gen 2X feature set. So it makes an enormous difference.
Yeah, and I'm gonna, because we're pressed for time, head to the next slide because it's similar data. It's also about Gen 2X. So Steven, Sorry, I'm going to have to cut you off on that one.
Okay.
But Trevor, if you could take 1 minute, we're bumping up against the Q&A time. You could take a minute to just kind of talk through this. That'd be great, and we can head to Q&A.
Yeah, so this is a similar setup. So imagine Valerie there is holding one of our handheld readers, because a lot of partners still use handhelds. And Gen 2X actually matters a lot in handhelds too. It runs on our E7 based chipset, which is what's in this particular handset. And on the left side here, you can see we've got a cabinet there, or I'm sorry, a shelving system there with a lot of really small items. So those are bottles of water, bottles of fluids for cars, they're cosmetics. So these are really small tags. Oftentimes, like in the automotive materials, you can take that cap off and there's a foil cover there. Those all work against radio signals, right? And so this is a very, very hard to read set of shelving materials. And in Gen 2 mode, which is the left side of this slide, we get 60 out of 72 reads. So we're intentionally trying not to get to 100, right? We're making it very, very hard to get to 100%. You put Gen 2X, you put it into Gen 2X mode in the same circumstances, and we get 69 out of the 72 items. So a 15% accuracy improvement, which, matters a lot when you're doing manual reads. You don't have to do rereads. You don't have to spend more time reading. And all of this just governed by the Gen 2X and M800 devices. So really very impressive improvements in performance because of the Gen 2X feature set.
Yes. All right. Well, thank you so much, Trevor. We're so glad we got to learn more about Gen 2X and about the tag portion of it, which is the M800 series, and the reader IC portion of it, which is the
E family. Yep. So the
E family series.
510, 710.
Great. So we're going to jump into the Q&A because we have over so many questions, over 40 questions. I want to
get the first one since he didn't get to talk on that slide.
Yes, that's what I'm going to do. Yeah, I know. Steven, I'm sorry. So I'm going to do one more poll just to see if we helped you out knowledge-wise. So I'm going to throw it up there. Did you feel like you learned more in this webinar about tag and reader ICs and the innovative features behind them? And if you put no, I'll just send the emails directly to one of these guys and say, that's on y'all. All right, so a lot of people did, which is great to see. So one other thing I'm going to do before the Q&A, I'm going to go ahead and add those handouts in here. So there's one that I'm adding right now. This is the Gen 2X video. So it's actually a demo video. It is really awesome. We also have a Gen 2X explainer video that I'm adding. And then one of the really cool things is we have a reader types infographic. So that can really give you a really good breakdown of bullet points of why to use which type of reader IC. If you don't download them now, we'll email you on Friday with all of the resources. But let's go ahead and jump into the Q&A. So I'm going to go all the way to the very top. And our first question from Tom says, I have an issue with read range. I'm using 127 millimeters by 18 millimeters in size tags. The problem is reading them at a distance of at least 40 feet. So we don't have more information, but Steven, do you want to take a look at that, or at least ask some questions to get him on the right path?
Yeah, I mean, I would need to ask some more questions to sort of diagnose that a little bit better. But I mean, there's a couple of ways that I think we could attack that, right? Like we would want to look at the anatomy of the tag that you're using, right? Like what IC is it using? Is it using one of the latest, greatest, most sensitive ICs? Another aspect is the tag size. If you have flexibility to use, and potentially a larger inlay, right, a bigger antenna, give the IC bigger ears, if you will. That's something that you could consider doing. And then also the antenna gain, the actual antenna. If you're using a fixed system, what is the antenna? What's the gain of the antenna that you're using? And then the last thing that I would consider is if you can pinpoint if the orientation of the tag is going to be the same every single time you're trying to read it, in terms of whether it's, mounted vertically or horizontally. You may consider using a different polarization, even maybe a linear antenna to really reach out and grab that tag. So it's certainly something we'd love to follow up with you on and give you guidance on some options to extend that read range.
Yeah. All right. One other one. Can you guys talk about RFID readability around metal? So that's a good one because there's been definitely some strides in the past 5 years, 10 years. So do you both want to talk about that, or Steven, do you want to kick us off on that one?
Yeah, I mean, metal is still a challenge, and I think that it just sort of depends on exactly what you're needing to achieve, right? We can't read through metal. Metal does still reflect the the UHF signal, but if you are needing a tag to apply to metal, there are a lot of good options. I mean, like this would be one. It would be on the more expensive side. It's a long-term tag, but there's also label type tags that are printable, right? You can run them through an RFID enabled printer and apply them to that product or to that piece of metal, and the tag will function really, really well. But when there is an environment with a lot of metal, we have to get creative, and where are we mounting antennas? What angle are the antennas, facing? And then, going back to the tag strategy, in some cases, in a high, metal dense environment, we may have to use a tag that would kind of be a little overkill for some other applications without, such high density of metals.
Oh, Trevor, do you have anything to add there?
No, I think that's exactly right. There are a handful of partners who specialize in those tags, and I'm sure the Atlas team could get you to those folks.
Yes, and we have great sample packs that you can try different ones. So,
Yeah.
and we partner with with Impinj and have a rain sample pack that's great for that. So I'm gonna give Trevor a tough one, and he can pass if he can't do this on the spot. But R700 has a sensitivity of negative 93 dBm. Can you explain what this means and under what conditions the sensitivity is achieved?
Yeah, the 93 dBm, the sensitivity is essentially the ability for it to hear a signal that comes back, a low power signal that comes back from a tag. And so a lot of readers out there are in the sort of 70 to 80 dB range. And so it's just like having a more sensitive microphone, so to speak, to hear somebody who's shouting at a very far distance from you. And the more sensitive your microphone is, the more ability you have to hear that person talking at a farther distance. Now, sensitivity is both good and bad. In that, if you are sensitive and you have somebody standing right next to you yelling at you, you can actually get more noise than you want. And so an example might be if you have a reader that is set to a very high sensitivity and you have a lot of tags that are very near a set of tags that you want to read. For example, let Steven use the pallet example earlier. Imagine a pallet full of shoe boxes that are all tagged. Well, you could read that pallet, but if you have pallets sitting next to the pallet of interest and you have a highly sensitive reader, you actually might get tags from those unimportant or not yet ready to be read pallets. So sensitivity is one of those things that needs to be managed as well, but it's effectively the ability to hear. And then you need to come up with different techniques for really reading the tags we call TOI or tags of interest and excluding those that are not that you do not want to read, or what we call stray tags, stuff that sort of pollutes your data, so to speak, for a clean read of the thing that you're really interested in.
Okay, great. So we have a very specific tag question. So Steven, you might answer this one a little bit like you did the first one, but what tag would you recommend to use on I think it's Scuba, an SCBA air cylinder and a fire hose coupler?
There are unique tag solutions for just about everything. As far as, like a scuba tank, an oxygen tank, right? We're typically, there are tags that are designed for that curved surface, right? And you could attach those tags using an epoxy. In some cases, you might even use a metal strap. I've seen, customers use like a metal strap through the tag to adhere the tag to a rounded surface like that. In terms of like hose nozzles or something along those lines, it could be something very similar where we use an epoxy to apply an on-metal tag. It's going to be durable, right? Durability is really important. Something that's going to be impact resistant, not just shear off or damage the tag itself and impact readability.
Okay. Awesome. So we have another one that could go either way. So I'll let y'all decide.
Sure.
So how does moisture affect the signals or the reads? So I'm guessing this is a communication between the tag and the reader. So I guess there's two parts, how is moisture in the environment going to affect it? And how is moisture maybe around the tag going to affect it?
Yeah, Steven, you might have a better answer. The way that I think about water generally is that water creates reflections in your energy. And so I don't know that it's so much about moisture as it is about either it absorbs signal or it diverts signal. And so remember in that forward link and reverse link, we were talking about the loss on either the forward or reverse link signal. Water or moisture or humidity is one of those components that will give you loss along the signal. And so, for example, like we were talking about a minute ago, metal is a very hard, because it's reflective, right? So it's sending signal, your electrical signal, all different directions. The same thing's true if you were to stick a tag, for example, on a gallon of milk or a gallon of water, and so that same water in the same way is reflecting or absorbing your energy. And so you just get a lot more signal loss. And so you have to take that into account when you're doing your forward and backward link calculation. Steven, is there a different way to think about it, or is that reasonable?
Yeah. No, I think that's exactly right. I mean, I think when they're like the metal dense environment, if you have a liquid dense environment or a liquid containing, you're trying to tag something that has liquid in it, right? Like I'm always looking for the airspace. Where can we put this tag where it's not going to be backed up against, a liquid or or submerged or something along those lines. Like I'm looking for the airspace, whether it's if it's like jugs in a box, the airspace at the top, that's what I'm looking for. Now, tags are waterproof, right? Like this tag could, you could submerge this tag. Nothing's going to hurt this tag. It has a high IP rating, but depending upon the depth in the water, right, you'll lose the ability to read. I mean, like it's not impossible given the sensitivity of the increase in sensitivity to read tags that are slightly submerged. But once you get to a certain depth, it makes it very challenging. And even those that are submerged, you're only reading them at a very, 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 very short read range typically. So, but yeah, I mean, water absorbing it or having sort of like this dispersion of the signal, right, is what keeps that from being a really effective, being able to read in those environments.
Yeah. I think so. I want to add on to that question, maybe twist the question just a little bit, because we're getting a lot of questions about tag readability. Yeah. I think one of the other things that I would really encourage is people are doing the proof of concept or evaluating their own situation. Orientation of antennas, readers, tags matters a lot. So for example, if my antenna is facing this way, sending a signal this way, and my tag is squared up to that antenna, I'm going to get a very strong signal back. If my tag is perpendicular to that antenna, I'm going to get a much, much weaker signal. If my tag is like somebody was saying, they had 127 by 18 tag. If that 18 millimeter side of the tag is facing me, imagine how much less ability I have to get at that antenna, to get signal to and from that antenna. So thinking about when materials are passing through your environment or passing through your system, how are they oriented? How is the reader getting to them? Do you have multiple points of read, for example, to make sure that you get all the orientations that come through? All of that, and this goes back to that tag strategy. Have a great tag IC, have the right tag with the right antenna size and type, and make sure it's oriented in such a way that the signal, now it doesn't have to be line of sight. That's one of the beauties about RFID, but having it oriented in a way that the signal is not attenuated across either your forward or reverse link is a really important part of getting good signal back.
All right, guys. Well, that is actually it. I feel like that Q&A portion went so fast, so maybe we should allocate more time next time. So the only thing I want to say is remember to download the available resources. They're in the handout section to the right. And I want to thank all of you for joining us. I hope you learned a lot. If you submitted a question, even if we didn't answer it live, we'll send you an email and reply to your question. Again, I'll send them to these two, and so you'll definitely get the right person answering. So thank you all again. Thank you, Trevor. Thank you, Steven, for your time. And this was a great webinar.
Thanks everybody. We really do value your time. So thank you very much
Yeah,
for coming.
thank you.
today.
All right. Thank you.